All right, there we go. I think we're ready. And let's unmute. There we go. And there we are. Welcome, everybody, all right, there, to another episode of our Labs Open Office Hour. This time, we're joined by Dr. Don Kinghorn, one of my favorite people to talk to ever because just your enthusiasm for the topic of any topic really is just so infectious. I love it. I'm really excited to be talking with you today. Like I like to always start off, just in case anybody doesn't already know, introduce yourself, give a little background, tell us a little bit about who you are and what you do.
Oh, okay, sure. Uh, I'm Don Kinghorn, Dr. Don. Um, the PhD is in theoretical chemistry. Uh, Done all kinds of things, but I've always been a computer nerd. So now I've been hanging out at Puget for wow, quite some time. I
Oh
think
yeah,
probably like 7 years or something like that.
wow,
Yeah, it's crazy, but it's fun. It's fun. I get to play with new hardware as soon as it comes out. It's always fun.
yeah,
I'm incurable hardware nerd, so um, yeah. But I'm the scientific computing advisor
yeah,
at Puget Systems. That's my main thing, and helping people do stuff.
right.
That's my motivation.
That's cool. I love it. And so a lot of what you do for Puget kind of relates to like machine learning and data crunching, and that's sort of an angle, right? There's a lot of TensorFlow and AMD and things like that.
Absolutely.
Yeah, that's pretty cool. Well, so to get to, I mean, that's a great start. So, I guess what's new in the scientific computing world, Don?
Well, I tell you, okay, just kind of like recent stuff I've been going. I don't have anything like really super special like to demo or anything like that today.
Okay.
But there's yeah, I mean, always there's been a lot of great stuff going on, and definitely one thing that I wanted to talk about is GTC,
Yeah.
NVIDIA's GPU Technology Conference.
Hmm.
That was last week.
Ooh. Oh.
And this was again, another live streamed kind of conference thing, of course,
Sure.
right?
Sure.
Um, and I really wanted to talk about it because kudos to NVIDIA.
Hmm.
Uh, they've they've always been like this. GTC is one of my favorite conferences, and been going for 7 years plus.
Wow.
Um, and it was just always my favorite. It's just been my favorite conference. You know, in the years ago, it was really pretty intimate. It was fairly small,
Yeah.
and it was really nice. They had these marvelous catered dinners, and I mean, it was great. It was really nice. Um, but it got bigger and bigger and bigger. Because
Hmm.
NVIDIA is like probably the most important company, one of the most important companies in the world right now, especially for computing, machine learning, AI. They're just,
Sure.
unquestionably a leader there. I
Yeah.
mean, they've
They,
they've been driving things forward.
right.
Um, and so the conference got huge. It just got massive, and they overflowed. Their venue. They kept the same venue down there, um,
It was Vegas.
but no. Uh,
San Diego. The conference center down there.
no, no,
Where would
no, no,
GTC?
no.
Where would
Silicon
GTC
Valley.
have been?
Well, where
Sacramento.
their home, right? Where everybody is.
Yeah, and where is GTC
Oh
location?
my God, I can't even.
uh,
It's like San
San
Jose.
Jose. There we go.
Yeah, man. For whatever reason, it's like San Jose. Is that
Yeah. Okay.
like? Yeah, of course it is. Yeah, sorry about that.
Hey.
But anyway, they overflowed that venue. I mean,
Mm-hmm.
it got just massive. The last couple of them were a little bit unpleasant because they were just so crowded.
Oh,
But the pandemic hit, right? It's
right,
like,
right.
oh, okay, well now we got to do something different. And so the one in the spring, which is usually the big meeting, that was uh, initially had been planning on attending that, right?
Right.
So had they. It was like, oh, okay. So they scrambled and they got a an online meeting going, and it was pretty good. It was pretty good.
Okay.
But one thing that NVIDIA has always done is they always get feedback.
Mm-hmm.
And I mean, even, all little things like on the conference, they're like, oh yeah, waiting it to get your pass, that was kind of a pain. The next year they fixed it and just like
Awesome.
tremendous improvement. They've done that every year. They always do that. They ask for your feedback and then they do something with it.
Shocking.
Imagine that, right?
Yeah,
That was
shocking.
shocking.
Considering
Um,
I've been to a couple Twitch cons and PAX, the Penny Arcade Expo, and it's a nightmare. Yeah, and
yeah.
so yeah,
Yeah,
that's good to
and
hear
you
somebody.
tell them that, and then it's like, well, okay, they don't
Ooh,
fix it.
yeah, what do you do?
But NVIDIA is really, really good about it. And
Cool.
this GTC, this is, they usually do, they would do a GTC in fall in
Mm-hmm.
like DC, kind of
Okay.
with a focus towards government stuff.
Okay.
And but the fall meeting this year, this was pretty much worldwide as they always are. Um, but they it was way better. It was very engaging. It was very good, and the talks, the streams they used. I don't know if you've seen any NVIDIA webinars, then you would know what I'm talking about. But
Okay.
they used their webinar format for their talks,
Nice.
and it was really, really quite good. And the that was the first thing, and it worked. I don't know the statistics for attendance and stuff like that, but I watched a lot of I was on a lot of the live uh, talk webinars, and they were very good.
Cool.
There
That's
was
good
a
to hear.
couple that I kind of suckered into that were like, Kool-Aid Fest.
Oh
You
yeah.
know, it's like, yeah, I've heard that marketing stuff, yeah. But but um, but the technical talks, and especially
Mm-hmm.
the NVIDIA people that were doing technical talks,
Yeah.
well, everybody actually that was doing technical, they were excellent. They were
Cool.
really, really good. And another thing where they listened.
Mm-hmm.
Uh, repeatability is a big deal right now.
Okay.
And
What do you mean for what exactly?
well, people, they say things and they do presentations and they show charts and they've got all these numbers and they're talking about all this stuff, and it's then like, okay, can I verify that somehow?
Oh, sure. Like
You know,
benchmarks and things, or like
yeah,
it.
yeah.
Okay.
And man, on nearly every talk that I went to, they had links to GitHub pages for source code. They had
Hey,
instructions. They had everything was like, okay, if you want to try this, here it is.
that's awesome.
And they were really good about it. They were really good about it. And that winds up being an extremely valuable resource,
Yeah.
you know, because that's good stuff.
Sure.
It's
Yeah.
it's just good stuff. And so it was obvious that uh, that was a requirement for the speakers,
Nice.
was to provide information for reproducibility and um, external links and stuff like that, sort code
Right.
links and stuff. So that was excellent. So I was really, really pleased with it.
Yeah. A lot more
Um,
toys for you to play with.
oh, it was good stuff, man. I learned a lot.
That's awesome.
Some of the talks were like, oh, that's gold. It was like, oh, okay. No, of
Was
course,
it
not
anything
going to do something, but
anything in particular standing out? That is
oh,
kind of mind blowing for you?
oh, Well, the, there was a CUDA technical talk,
Okay.
and it was just great. I mean, the advances they made in in version 11 of CUDA.
Hmm.
I don't have anything right offhand, and I'm not remembering anything right. Um, but it was really impressive, and it was just a great talk. And it kind of the big picture there
Hmm.
is that they're just they're just they're just killing it. They're just
Yeah.
moving forward in a massive way, and it just keeps getting better and better and better. Um,
Yeah.
so yeah,
It has seemed that in a big picture kind of way, Nvidia is definitely more is focused on the like scientific computing, the machine learning, the AI kind of stuff, and they really just like their gaming stuff is just a front for all of the cool science stuff that they kind of do in the background. And I feel like maybe some people miss that. That Nvidia really like a lot of the stuff. I mean, everything from like automated driving to, man, it boggles the mind. You know, these something as simple as like is this a hot dog kind of thing, but like the underlying like principles there are mega. I mean, look at the Nvidia broadcasting where it could cut me out of this right here and without a green screen, and it's crisp and really really well done. The RTX voice thing, those are more like consumer facing sort of products, but all of that has been funded and powered by their scientific stuff that they've been doing, and it's really really cool.
oh, it's amazing. Yeah, they're they've and you're right about the gaming thing. I mean, because that's what funded everything.
Yeah.
And and you know and Jensen, I mean, he had a vision, and and
So
G4,
this kind of
the
been
gaming.
their that's been their plan from the beginning, kind of.
Well, they really quickly caught on to what we did in, oh man, mid 2000s.
Okay.
Because I toyed with this stuff right off the bat before CUDA.
Yeah.
It's like, oh, hey man, these shaders are cool. These are little four vectors in here. I wonder if we can compute with this. And so people started toying around with that. I was like, oh man, these video cards are freaking killer. Okay, so yeah, you can actually do some matrix multiplies on a video card. And so there was a big interest because accelerated. People were kind of hitting the wall on some CPU stuff, and it was like,
Sure.
man, we need something. And Nvidia was going, ooh, yeah. And and I mean, they had to be really looking towards the future. Uh, but then they took that money because they were really killing it in the gaming GPU market. So
Right.
they were very profitable. They took that money and invested it in on the computing side, and created that just insanely great ecosystem around CUDA and GPU acceleration. And
Hmm.
I mean, I always say it, if you want an example of a superb ecosystem for a platform, NVIDIA just nailed it. And they just keep doing it. And then they were pretty much responsible for the machine learning AI revolution.
Sure.
I mean, it was because I did this stuff as a messed around with some of it as a grad student in the early 90s.
Hmm.
Okay, I just cleaned a folder out of a file cabinet the other day, and it was like I have papers in there from 89. And
Wow.
this is stuff I was looking at and kind of messing around, but you couldn't do anything. Couldn't do anything because the
Yeah.
performance wasn't there. The
Hmm.
data revolution hadn't happened and all that. Um, but yeah, Nvidia caused that to just explode. And um, and they're the main force driving things forward because they've got competition with other accelerators and other stuff going on, but man, they just keep moving forward
Yeah.
every time, it looks like, oh yeah, maybe Nvidia is going to get unseated, and then it's like, no, they're not.
So we actually have a question from Twitch. Deddy asks how long. I'm going to paraphrase a little bit, but how long do you think before machine learning and AI is going to be more friendly for beginners, just like Raspberry Pi kind of took the route for coding and whatnot?
That's a great question, and I mean, that one gets to me personally because, um, and I struggle with this a little bit sometimes too. Part of the stuff that I do here and that I really get a lot of satisfaction from is is helping people to get started with this stuff.
Mm-hmm, mm-hmm.
Um, that post that I did, man, the post is it's got to be almost 2 years old now about how to get TensorFlow with GPU support going on Windows.
Oh, sure. Mm-hmm.
That's been that's been one of my most rewarding posts because I don't know, there's hundreds and hundreds of comments on there. And it usually goes something like, "Oh man, I was trying to get this going for a week and I couldn't. Nothing worked right. I followed your guide here, and now I'm up and running, and I've got TensorFlow going, and I'm back to my school project."
Nice. I'm gonna
Um,
post that into the chat. This is the one. This is the one titled "The Best Way to Install TensorFlow with GPU Support on Windows 10 Without Installing CUDA."
I think so, and it's probably got like an updated at the end of it.
Yeah, new version of this post now available. Yeah, we'll get you the fresh one from 2019, April 26, 2019. Here we
Okay,
go.
yeah, it's still I've kind of thought that one needed a refresh, but because periodically some of this stuff doesn't work right,
Sure.
it's because there's a lot of moving parts and like some things like, oh, that's not working right, but it's everything in there is actually pretty much okay right now, and the basic principles are sound, and I mean that's the
Okay.
best way to get the setup going, and it's pretty straightforward. Um, oh geez, hey, you know what? I'll honestly, my recommendation for really for serious machine learning work and stuff like that is Linux.
Sure.
And the reason is because that's where all of the development work is done. That's where all the
Oh.
research is being done, and that. Um, but if as an entry point, no, man, use your Linux or your Windows gaming rig.
Sure.
I mean, that's just killer for a machine learning. You got a halfway decent Nvidia GPU in there, and you're set. I mean, you could do serious work.
Mm-hmm.
Um, and it's getting easier and easier and easier to do. You could do a course like Fast AI.
Okay.
Um, that's I highly recommend it. I haven't done their stuff, but I mean, it's really good. It's kind of like uh, they do kind of a top down. It's like get your hands in there and learn how to do some machine learning work, and and then kind of do that from the top down, and then more theory exposure and stuff as later as you go. So yeah, good resources, and I encourage anybody that's hesitating, that's like, oh, it's go ahead and dive in because there's a bunch of good stuff.
Yeah.
Um, but another thing kind of related to that, I'll since it came up, I'll go ahead and say that I'm one of the things I've been messing around with is I'm trying to get um, trying to do I did the machine learning development server stack.
Yeah. Yeah.
Okay, that's a work in progress. It's pretty good. I've got people using it in the field. They're using it for teaching courses and stuff like that.
Nice.
That's a Linux server based
Mm-hmm.
stack based around with an administrative. It's all accessed through a web browser. So
Oh,
everything
that's
on the
right. Yeah.
machine, it's a server, and I have a system administration interface that's really easy to use for like managing users and doing updates and all that kind of stuff right through the browser.
Mm-hmm.
And then I've got Jupyter hubs um, serving up multi-users accounts on the server, and then that's serving up Jupyter Lab as the primary user interface,
Mm-hmm.
and then configurations in that for doing this stuff. Um, and that's pretty nice. You know, I'm a little bit stalled on it right now because I'm waiting on Jupyter Lab version 3, and
Oh,
it's been delayed several times. So, and
bummer.
that's but it's JupyterCon is going on right now,
Right on.
and
Okay.
they're releasing it like this week or next. It might be next week.
Hmm.
Um, but that will get packaged up and everything soon, and then I'll do a new version of this stack, and I'll
Oh, cool.
base everything around Jupyter Lab 3, and that should be pretty cool. Um, but I'm also looking at now that's server oriented. This is for
Hmm.
doing like a
Hmm.
heavyweight machine where you've got, not a lot of people, but a, 4 or 5 or 6,
Sure.
small group. It's also it's appropriate for doing like classes that could be, 30 or 40 people even.
Right.
But you can't give
Wow,
everybody
that's really
their own
cool.
GPU there yet.
Yet, yeah.
Um, um, oh, I keep hitting all these wonderful little tangents I could go
Yeah.
off on.
No, no, that's great. No, it's good. It's good.
But I'm working on doing a stack,
Hmm.
an end user stack on Windows.
Right.
Okay, something that I want it to be actually instead of having to go through all this setup and stuff like what I've got in that blog post, more of like, okay, download this installer and run it, and it'll set everything up for you. You're ready to go.
That'll be cool.
Um, there's some barriers, there's some difficulties in doing that, um, but I've been messing with it. I've been doing it. I've also installed my stack
Hmm.
on Windows WSL2.
Right.
I've
Yeah,
installed I've
we did
installed
a
the Linux stack on there with
yeah.
GPU support, which is
Hmm.
not public. All, that's in the
Oh, right.
insider uh,
Yeah.
dev channel and all that right now. But that
Hmm.
actually works pretty good, and that's an interesting way to do it.
Yeah.
And going forward in the future, that will be the way to do it. It'll be using Linux on Windows. That'll be the way to do stuff like this.
That's cool.
Um,
Yeah, we did
Massive.
a demonstration of that a couple. I think that was our last talk. You and I was the WSL.
Oh,
Um,
did we? Yeah, we did it a couple
hmm.
times because I
Hmm.
when it was first possible to do, I did something and then I did another one. Oh yeah, yeah, yeah. I
Hmm.
think I fired up like Jupyter Lab and stuff like that
Yep, I
on
remember. And then
WSL
you
with GPU support.
there was a you
Oh, it ran a
downloaded
little.
an Nvidia Docker container that was specifically
Yeah,
built for
yeah.
Linux, and it ran perfect, and it was super cool. I remember that was neat. I remember you were so excited, which is, and it is because
It's cool.
most, like, with the penetration that Windows has, basically everybody has Windows, and here pretty soon they're going to be pushing this WSL2 out to everybody, and so it's just going to be, it'll be an option, like it's not going to be in your face, but anybody will be able to just take a few fairly easy steps. It looked pretty simple as I recall, and you could be doing cool machine learning
You
stuff.
could be
That's
running NGC. That's the NVIDIA um, GPU containers on Windows.
yeah.
Okay, and using that great stuff. Yeah, those Docker containers from NGC are fantastic. And that's yeah, and that
Cool.
probably the performance is getting pretty reasonable.
Mm-hmm.
For the GPU, they're they're doing Microsoft's doing fantastic stuff with this. That team is wonderful. Um, so and Nvidia is totally cooperating with them,
Nice.
which is really really great. So that's yeah, it's going to be interesting to see what goes forward on it. People are speculating that Microsoft's going to drop the NT core and use a Linux core for
Ooh,
Windows.
interesting.
I think that's really pretty far fetched
Yeah.
because the basis of those operating systems is really, really different.
Okay.
So, but in some sense, it makes sense. I mean, some big people are speculating on this, and they have good arguments.
Hmm.
But I really doubt it.
Yeah.
Okay, but who knows, man? Who knows? The thing is, it may be moot. because I think that the Windows and Linux are going to be running pretty much on par performance on the same machine on the same desktop.
Oh, cool. Okay.
And that's probably less than a year away from that being like, hey, really something viable.
Nice.
But yeah, I really kind of went off on a tangent
No,
there, but
that's
I
okay.
think that's appropriate for today.
Yeah, no, that's all right. So we do have actually Deddy from Twitch has another couple questions. Have you had any chance to play with Nvidia Jetson? And an interesting segue that I knew we would come to. What do you think about the future for ARM CPUs?
Ah, nice. Okay, love it. Hang on a second. I'm going to grab something. I'm just going to grab something. I think my cord will reach this far.
Don gets to show off his toys. This is great.
I did this, and I was all enthusiastic. I wanted to get a whole team going down at the company to do this. But
this is cute. I love this.
See, here is, oh man, the camera is like,
yeah, there you go,
oriented backwards and stuff. That is an Nvidia Jetson in there. And that thing is fantastic. It's great. I mean,
it's only like $100, right? They're pretty cheap.
It's $100. Yeah, this is the original one, the 4 gigabyte. This is actually a decent computer system right here.
I love it.
It's got a Maxwell GPU in it with a decent number of cores. A Maxwell-like GPU. It's actually unique, the one that's in here. But that's a little ARM, an ARM unit with an Nvidia GPU in it.
Right on. So you got yourself a little battle bot right there.
Yeah, I've got the camera. Yeah, I've got a little display on here. Oh man, I got to change the orientation of the camera. It's driving me crazy. Little display on there. It runs off a battery. The idea with that was to do it, as an autonomous robot.
Oh, neat.
And just use the camera and just, I had this vision of everybody making their little robots and then like putting a number on the back of their shirt or something like that and having their little robot follow them around the parking lot.
Oh, that'd be neat. Yeah.
But we should probably still do that. Maybe we'll do that in
really
the
cool.
summer. It'll be awesome.
Yeah.
But yeah, Jetson is great. Don't hesitate to pick one up. And especially, that was one of the things they announced at GTC is they've got a 2 gigabyte version of that.
Oh, nice.
Which for projects and stuff, it's okay. This is this little ARM thing running Linux. It's pretty lean, and that thing is like $60. It's like $59 or something like that.
Man, that's nothing.
That's a no-brainer. Yeah. Hey, if you haven't gotten one and you're hesitant, just get the stupid thing. I would probably say get the 4 gig one because you can set up a Linux desktop on there that was actually really a pretty decent little box. It's crazy.
That's awesome.
Yeah, that's fun.
That's cool.
Fun. Good stuff.
So ARM, I know this past year or so, the #1 supercomputer is a massive ARM thing. I don't know the right word, but
the machine by Fujitsu.
Yeah.
They were the first ones that hit exaflops.
Wow.
And
so hold on. Let's give a little perspective. What is an exaflop?
Let's see. Exaflop is like is that a billion?
Because I know recently in casual news, the most recent consoles that are coming out here pretty soon are I think into the gigaflops. And so how much more than that?
Okay, gigaflops. You go to.
I think.
Okay, you go to like teraflops, right? Which is 1,000 times that.
Oh,
so,
my
teraflops.
My bad. So the Sony PS5 is capable of 10.28 teraflops. So as a comparison,
that's in some sense, it is. Yeah.
Sure.
But that's because that's Yeah, that's pretty amazing. Um, but yeah, so a teraflop is 1,000 gigaflops, then
Uh-huh.
a petaflop is 1,000 teraflops, and then a exaflop is 1,000 petaflops.
So we're looking at
So it's like I think that's a
10,000.
billion billion, like a million trillion, right? I
That's
mean,
a lot of
yeah, it's
zeros.
way up there.
That's a lot of zeros.
Okay, it's insane. It's just crazy. Um, but
Wow.
yeah, ARM is oh, okay. If you really want to, uh, I've been pretty big on ARM for a couple of years, and in fact,
Yeah.
I thought it was going to take off in a bigger way sooner.
Okay.
Um, and a couple of years ago, I was bugging Josh,
Hmm.
our guy that does system design and qualification.
Hmm.
What's his official kind of title?
Uh, product manager.
Product design engineer or something like that. But Josh is great. And
Yeah.
man, I was just bugging him. I was just driving him crazy. I walk up to him, I'd whisper in his ear, I go, "Arm, arm," and um, but
Yeah.
and at that point, I was thinking, hey, maybe we could do we could do an ARM workstation for developers to, actually have a good development platform that is ARM based.
Oh.
But it was not really such a great idea at the time. I
Okay.
mean, it would have been okay, but nah,
Who do
not
you
worth the headache.
who do you go through for ARM? Like, is that still like Intel and or Citrix? Like, who does
The,
or
okay, yeah, it's ARM is really interesting.
Nvidia soon, but like who does
Yeah.
ARM?
Well, ARM is a weird model, okay, because ARM itself is intellectual property licensing.
Oh,
They
okay.
they do design and they
Oh,
control kind of the specifications and stuff like that, but they don't make anything.
okay. That'd be like the Snapdragon processor that's in my phone or
Yes.
some and
Yeah.
some
Yeah.
and Samsung or whoever makes that.
Yeah.
Okay.
And that's the scales all the way from little teeny things that are driving everything, right?
Mm-hmm.
All the way to like serious HPC processors, like the Fujitsu one is probably the highest performance right now. I think that's like a 64 core. Um, it's 64 bit. It's got vector acceleration. I mean, it's a serious HPC supercomputer chip,
Yeah.
and there's a few designs. But there's that stuff is still it's evolving like again right
Mm-hmm.
now, and so yeah, ARM can scale from, you know, what's in your toaster up to supercomputers.
Wow.
So um, and anybody that licenses the design can make their own ARM processors.
I see. Okay.
So like Apple has their own processors,
Mm-hmm. Mm-hmm.
right? That's their processor based on the underlying ARM design.
I see.
Yeah, yeah. ARM is a kind of an old school RISC processor, reduced
Mm-hmm.
instruction set processor. A great processor, but that's part of the reason why it's lower power. It's very different from Intel and AMD.
Hmm.
It's like the old school Unix systems used to
Okay.
run on um, RISC systems, but ARM is the survivor of that model. Um, but yeah, there's a really, 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 really compelling reasons for companies like Apple and Microsoft to move to a hardware platform that's ARM based,
Okay.
because it greatly increases their profitability, for one.
Hmm.
And they could build systems that are high performance with very low power consumption.
Okay.
You know,
That's cool. That's
these
cool.
big ones, they suck the juice just
Oh
like
yeah.
everything else,
Yeah.
but it is more efficient. And the thing is, they can control the design process a lot more.
Hmm.
And yeah, there's really compelling reasons. And Apple's making the switch.
Yep.
Microsoft is yeah, they're going to do ARM.
I know that they've had, having spoken with my friend Jerry, he used to work for Microsoft. They do have a version of Windows 10 that is built for ARM, and so I think really the only the hang up I think is the I guess virtualization, I suppose, because we have so many popular applications that are written for the x86, x6 or 64-bit like
x86.
And that that's not the same, and so trying to get those to cross over is difficult, is from what I understand.
But they've had really good success recent. They essentially have to emulate the instruction set,
right?
Because there's and that's part of the reason why it's been a big lag. As you're in the process, the transition process, they'll have to use some emulation to keep a lot of mainstream applications up and running until they get native ports done.
Okay.
The thing is, it's getting easier and easier to do the native ports.
Oh, nice.
That's
nice.
Yeah, that's one of the big changes. Nvidia's all in, obviously.
Right.
Because unless it gets blocked for political reasons, Nvidia will own ARM.
Okay.
And they have already ported everything to ARM. The full CUDA, their entire SDK, their entire development stack, everything, ARM is fully supported now. It's completely supported.
Nice.
And they have product. They have new product, that server class product that is GPU and ARM based, that then slots into backplanes. Nvidia is just they're flying forward.
Yeah.
And whether they acquire ARM, if they actually acquire ARM, it will just be a boost for them.
Sure.
But if they don't, if they're blocked, it's not going to matter.
Sure.
Because they'll still do, they've had their own ARM design. They've got Tegra they've had for ages. And but they will definitely move forward in the HPC realm of ARM. And so Nvidia will probably have high performance hardware that's, even more power efficient.
Nice.
And they'll be when they can control the whole design. And they've got Mellanox, so they've got the communication stuff, the high performance networking. They've got all the little pieces there, but they still need a CPU.
Sure.
And if they acquire ARM, it will definitely be an advantage to them. It will also be another revenue stream for them, a very important revenue stream.
Because then everybody has to license it from them.
Yeah. And the thing is, people are kind of worried about Nvidia owning ARM. I think it's totally great. Nvidia is not an evil company. Nvidia is an amazing company. They still have marketing, and they do stuff that every now and then you go, whoa, come on, guys, no,
the 20
don't
series
do that.
prices, right?
Well, yeah, but that's the game in business, but the core of the company, especially the new Nvidia, right? Man, they're doing really, really good stuff, and they're a very important company.
Yeah,
they're very important, and if they get, oh man, if Nvidia gets ARM in 5 years, we're going to be looking back and going, whoa,
everybody,
what happened?
Yeah,
everybody.
So I suppose this question's come up a couple times, so we'll just touch on this real fast. Will it be possible to have a quad RTX 3090 workstation on a 1600 watt power supply? Do you think some lower power blower versions might come out?
Maybe and yes. Okay, yeah, it's. Oh, hey, we are chomping at the bit, and in fact, Matt is testing. Matt is doing some testing with quad.
Matt put a picture out of
yeah,
and it's been blowing up. People have been talking about it a lot. Yeah. So I had to touch on that real quick. But to swing back to the ARM discussion, what as a consumer, what would be the benefit of a shift to ARM?
Lower cost and more efficient power consumption.
Yeah. So that's where the Quad 3090 would come into play, because then you have a lower TDP CPU. You could stuff 1,200 watts worth of graphics cards into a machine.
Will have its own CPU, and they'll be networked with Mellanox interconnects. So it'll be a complete. I mean, I can kind of see some stuff into the future that Nvidia could do that will just be like completely different.
So I kind of jokingly said at one point that like we're getting to a point where graphics cards are basically another computer that you're just sticking. My computer has a computer plugged into it, and like what you just said makes that a serious statement. Like this could be its own, like kind of in a way it's its own standalone little PC, kind of that then but they're all system. They're sort of networked together via the motherboard. They're a bunch of like almost like daughter cards, kind of in a way. Wow,
it's really close to that already, and but yeah, it'll just be tighter integration, so that it will the way NVIDIA's rolling. Man, we'll probably see some like really game changer stuff even just by next year. Wow. By the end of next year, early 2022, probably won't even be recognizable as like from stuff that we have today.
Wow.
As far as how it goes on the workstation side, I don't know, man, because you know the x86 processors are the stuff is very, very good. AMD is knocking out some outstanding stuff right now.
Yeah.
And it's available. You know what I mean? They can deliver it. Sorry, Intel, but
hey, that's the truth.
And so that stuff is really good. It's really good, and you know, and there's legacy there, and it's almost impossible to change platforms. I mean, totally. I mean, it's extremely difficult to do that.
Right.
So, x86 is going to be around for a while. It's not going away, and it's going to still be very, very important. And it may still dominate for like workstation platform. Okay. I don't know how ARM is going to fit in there, but somebody will probably come up, will do something pretty innovative. We may see that next year. We'll, have to wait and see. It's a little bit hard for me to pull out my crystal ball at this point.
Yeah.
But AMD is really impressive. I really like their new processors. I'm super looking forward to seeing Zen 3 across the board. Zen 3 Threadripper and the Epic Milan, the new Epic version. I'm actually hopeful, and I got to bug Josh. I need to go up to Josh. Epic, where's my Epic?
Yeah. We haven't been hearing a lot, or at least the tiny piece of the pie that that because of Puget, that Epic it wasn't as good as Xeon, or had it made its place into the server side of things.
They're making big inroads with Epic.
Oh, good. Okay, cool.
And Nvidia is totally on Epic now. All the hardware that they're selling is all Epic. It's nice. Because they want the PCIe 4. Aha.
Okay. Yeah.
And Epic is really strong. One of the people that's on here, Ron, my good buddy, he's got an insanely killer Epic box.
Nice.
But we couldn't build it for him. It broke my heart. But he's got 4 GPUs in that puppy, and this thing is it's the most crazy. It's right on the edge of being feasible to do. I mean, it's like got to be using up an entire power line.
Oh yeah,
And
like its own 30 amp circuit kind of thing.
probably 20 is okay for that. If
Okay.
15 is squeaking by. Um, but
Can't run the toaster at the same time.
yeah, really, you can't. Um, the but he's doing great run. He's doing insanely great stuff too. So
Nice. That's cool.
but that's cool. But I would like to see a lot of our stuff more on the scientific side and HPC side, probably be rebased onto EVIC.
Okay. Okay.
So, we're being very, very cautious about moving forward on that. And, we qualify everything. And there's been these little gotchas that has just kind of prevented us from doing some things. But it's getting better and better. And we should have some stuff. And I expect really to shift some platforms over.
Sweet.
Not that the Intel stuff is bad, because the Intel stuff is great. And I absolutely love the Xeon 64L stuff, the 64 lane. That's a great platform. That's really, really good. I don't hesitate on that, not for a second. So yeah, went off on a tangent there.
No, that's all right.
Yeah, probably a good one. That was a good tangent.
Yeah, Ron says it heats up the office on its own 20 amp plug.
Yeah. Oh yeah, totally. I mean, yeah, I had to. Yeah, that's a great. I mean, that's an insane box.
I hear another comment. This is a little more general, kind of labs question.
Sure.
It says Linus Tech Tips says there are voltage spikes with the 30 series, so they need more power than they claim to need. Have we found similar? Do you know?
Okay. We haven't done that kind of testing. Okay, but we're looking at pushing the envelope here. Like, see, okay, can we do quad? Can we do 4 GPUs? What do we need for power? How can we manage that? I had just a little short kind of brainstorm exchange with Matt this morning.
Yeah.
And one of the things that I thought came to my mind is like, oh, hey, because we have design limitations on this stuff, and this is something I've talked with John about for years and years and years. A lot of the systems that I used to design myself personally, the limitation criteria that I gave was that it had to be able to run on a single 20 amp line.
Sure.
And so you have power limitations, and for us, we need to restrict that to a 15 amp like residential, a US 15 amp residential line. And so there's a limit to the power draw that you can have and still have a stable system.
Right.
Now, as far as any kind of spiking or anything weird like that, that's hard to say, because this could be from early manufacturer stuff. You know. And I know there was a little bit of design looseness.
Oh yeah.
Say, and a few GPUs have had some issues. But I don't know of any real serious showstopper there with spikes. But the idea that I had this morning, and I kind of like this, and on laptops, Nvidia abused a term called max Q. That has to do with pressure, dynamic pressure, but it's the idea is that there's a sweet spot.
Okay.
So if you look at as far as compute goes, the A100 compute cards are TDP'd at 250.
Oh, nice. Okay.
The PCIe cards, and actually we're going to be offering those soon. Okay, so we'll be able to put that in some of the server gear, and I really have some uses for that. Okay,
Nice.
because those are way different than
Okay.
the RTX, any of the RTXs. It's way different.
Okay. Okay.
And some amazing features on A100. Um, but the PCIe A100, 250 watts.
Sure.
Okay.
And that's not so bad.
So yeah, and so the power draw is really high on these.
Yeah.
Maxing up to like 350 watts, right?
Mm-hmm.
This was kind of the idea that I had. There's probably like 90% of the performance that you could get probably close to 250 watts. On laptop, you buy a laptop, and a lot of times you'll see this marketing thing that'll say max Q.
Okay.
And what that is they basically looked at performance, then they looked at power draw, and there it goes up almost linearly, performance and the power draw, until it reaches a point, and then it starts to roll over pretty sharply.
Huh.
Okay, to where
Okay.
you have to add a lot more power to get just a little bit more performance. And there's a peak in there. There's a point where it's really it's optimal, and
Right.
they're calling that max Q.
Hmm.
For laptop GPUs, because they need to conserve power. They need to
Right.
conserve battery life and not burn the thing up, right?
Right.
So,
Right.
so I'm looking at that. I'm going, well, heck, man, maybe I can do some. I can use the management library, the NVML,
Okay.
or the even the Nvidia SMI
Yeah.
management interface, and you can control the voltage. You can control the power draw on the cards.
Sure.
Okay, so you can cap them, and you can do this dynamically. So I think I can plot one of these max Qs for like the 3090,
Yeah.
and there's probably a sweet spot in there where you're
Sure.
getting
Sure.
a lot of performance at a reasonable power draw.
Yeah.
Now, for multi GPU, that might make a machine that's viable versus something that's not practical to do.
Sure.
So I'm not sure how to do it, because we probably want to do it dynamically. Because
Right.
if you've only got a couple cards in use, yeah, you don't want to cap them. You just want to let them
Yeah.
run.
They'd be fine to
So
look.
you'd have
Yeah.
to do an accumulation across the cards
Mm-hmm.
and look at the cumulative power draw, and then dynamically adjust it based on the load.
Wow. That'll
So
be fun.
it'd be tricky. I'm going to mess around with it. I'm going to play with it. I at least want to do a max Q for one card, just to see actually where that power and performance sweet spot really is.
Okay.
And there's some people that may actually really want to do that, because you can cap the power draw. You can limit the GPUs, and I'm pretty sure that you have full control of that on the RTX 30s.
That'd be cool.
I haven't tried this yet, but I'm pretty sure that you can. Almost certain. So I'll mess around with that and see. It'll be fun anyway. In any case, it'll be fun.
Yeah.
But yeah, blower cards. Yeah, they're going to happen, and that's essential. Okay.
Right. Right.
Because you have to be able to get that heat out of the case.
Mhm.
And you can't just blow that much, because every watt, right? All that stuff becomes heat.
Right.
Power in,
Right. Of course.
it becomes heat. There's a little teeny bit of it that gets converted into actually computing something, but
Sure.
most of it is heat.
It seems wasteful.
So yeah, you generate a lot of heat for the amount of computation that you're getting. So yeah, we got to get that out. So, I'm very optimistic about the blower cards.
Yeah.
Okay, I think they'll be good. They're coming from a really great manufacturer who I have tremendous respect for. Is that public information yet?
Well, I mean, Matt posted a picture of 4 blowers in a machine, so
Yeah, yeah, and those are the.
I don't know. I don't know that he mentioned a
I don't know
brand, but I
what
don't
those
think
really
he. I
were,
don't.
but yeah, but that's the company, right? Okay, that's Gigabyte.
Yeah.
They
It's
made
fine.
some of the best 2080 Ti's, in my opinion. I loved their design on the
Oh
2080
yeah,
Ti. Uh,
they were great.
yeah, I and
Yeah,
so I
it says right on the edge there gigabyte. So we're if we
okay,
were gonna
yeah,
get in
okay,
trouble, we would have already.
yeah. Anyway, that's totally. Yeah, I haven't seen these yet.
Oh geez, actually,
Okay, I haven't messed with
just
these yet.
about just about 20 minutes ago, he posted a picture of two 1600 watt power supplies powering four
Oh God.
3090s.
I used to do that.
The office is
Um,
gonna explode.
I I I was doing consulting. I was doing hardware designs and shipping scientific workstations on the
Yeah.
early days of GPU compute, and I was building systems with multiple power supplies. And
Wow,
having
that's
them relayed
crazy.
together.
Yeah.
One power supply be running a couple of the GPUs, and another one against the motherboard and the GPU. And it's like, yeah, you could totally do that.
That's crazy.
Yeah, see, that's the thing. We need to come up with a practical design, and um, I'm really curious about,
I think
because there may be some serious advantages to like having 4 GPUs
right,
with a little bit of a capped power draw
right.
versus 3 that are uncapped. So
Yeah,
that's
sure.
a big up. That's because
Because
I'm going. Yeah,
because
I
yeah,
have a feeling that max Q is going to be high.
right. Like
We'll get a lot of performance.
it'd be better to have 4 of them running at 80% than 3 running at 100. Right? You're getting
Probably.
more total oomph, even though
Yeah.
yeah, yeah,
Yeah,
that'll be cool. I'd love
I
to see
wouldn't be
what we do with
surprised if
this.
we can get a power draw down to 275, 280 watts and still have really, really, really great performance. Um, I'm super curious about that because it's like, ooh, I think I can check that out. So yeah, I'll probably try it. Um, I'll just say my testing and stuff is kind of on hold. I've had a weird couple of weeks. It's
Yeah.
like everything that I've been like, okay, this is what I'm working on. Like, I can't do that. Oh, I'm basically I'm stalled on a lot of stuff. Um, but one of the things where I'm kind of stalled is I don't really want to do much more testing on the GPU until I've got better until I have framework rebuilds.
Right.
CUDA 11.1 now has support in it for the GA 102 processor, okay,
Mm-hmm.
which is different than the GA 100. And um, so yeah, when I did the testing, there was like, oh, this is not working right. That's not here. Oh man, the PTX is going to the driver for compilation. A lot of stuff is not super great there yet for on the heavy computing end of it, that running TensorFlow and PyTorch and all that.
Right.
So um, but been going, oh, okay, it's time for me to bite the bullet and do my own compile and try to link TensorFlow up with the bleedingest edge library releases from Intel or from Nvidia, and see if I can get the thing going and get some better performance. But what I want to do is wait for Nvidia to do it.
Sure.
And I think by the end of the month, they will have some updates. I don't know. They
Oh,
don't
cool.
have a big motivation for doing this, but I expect them to have updates to the containers on NGC that are rebuilt to CUDA 11.1
Okay.
and CUDA DNN 8.4. I think it's 8.4. Whatever. It's
Yeah.
CUDA DNN 8,
Okay.
and that's because I felt like I was leaving performance on the table when I tested these GPUs. It's going, I think there's more stuff that could happen there.
Interesting.
Um, some of my commenters really pointed out some stuff that's like, whoa, yeah. Okay, maybe that's what we're going to see.
Hmm.
But I'm still optimistic that there's more optimization to be had.
Nice. That's
Um,
good. Yeah.
so, but I'm expecting it probably to be like mid-November um, I before I have a new driver and some
Mm,
new
mm.
framework builds, and just kind of for all the software and the stuff to kind of catch up to the max capability we can get out of the GA 102.
Yeah.
So, but I will definitely be doing, more testing. Um, yeah, it's great. Oh man, we got good
It's
stuff to
gonna be
play
good.
with right now.
Yeah, it seems like we're on the cusp of a kind of a new frontier almost. Like there's another
Some nice.
major leap forward.
This this was a big leap forward. And these GPUs are great. I mean, oh my God. And AMD's Zen 3 is looking really good.
Mm-hmm.
That's going to be good stuff. We will definitely have testing up on launch. I'm gonna do some testing. I haven't done anything yet.
Right.
Um, I'm gonna kind of wait. I'm waiting more for the last minute on my testing, um, because I'm gonna test on Linux.
Yeah.
And I want to talk to AMD a little bit and see if they're going to have an updated, some libraries updated for compute performance. I don't think so. I think
Mm.
that's going to be a little while out before they have a new version of their Bliss library, their BLOS library, and
Mm-hmm.
Flame, their LOPAC stuff.
Mm.
So I don't think it'll be fully optimized for performance wise, probably for a couple of months.
Okay.
But I'll get some numbers up and try to get some comparative stuff. It looks like an incremental improvement over Zen 2 Plus.
Okay.
It's not like a I don't see any there's some design changes that are really significant, and everything that they said, I think you can take it as being like, yeah, that's for real.
Okay.
Um, and um, um, I'm looking forward to Zen 4 because
Whoa.
I'd like to see a major architecture update. Although
Sure.
their design is brilliant. And they've just Intel's going to be just kicking themselves
Yeah, I bet.
because AMD beat them to this by it's going to be over a year, by a year, well, 2 years. AMD is going
Yeah.
to have beaten them to this whole idea with these chiplet clusters.
That's
Um,
great.
and so AMD's getting good yield because they don't have to have as much, they can just they have they can afford to have more things broken uh, uh, that they and still have good stuff. I mean,
Yeah.
it was brilliant. The current AMD design is brilliant. I mean, yeah, kudos to
Yeah.
Lisa Su. I mean, she,
High fives all around. Yeah,
yeah.
I know just from the consumer side it's exciting stuff. Yeah, I'm looking forward to, heck, I mean, even just the current generation of AMDs is killer, and so
It's
yeah,
really
I mean,
good.
so yeah, if
I
they
love
keep
the
riding this
32 core
train,
with Threadripper.
it's great.
I think that's one of the nicest processors available right now.
Yeah.
I mean, it's nice. So I'm looking forward to the Zen 3 Threadrippers.
All right.
Um,
We have a little bit gone over our hour. I'm
oh
gonna want to
yeah.
get one more question out, and because
Sure.
I'm curious to know what you think about this. What are you waiting for quantum computers? This is from Timo TT on YouTube.
I have some involvement with quantum computers. Okay,
Oh,
I'm a theoretical chemist, and
right, right.
that means quantum mechanics, pretty much.
Mm-hmm.
And I have some colleagues that have basically been carrying the torch of research that I did at the University of Arizona
Mm-hmm.
years and years ago. Um, and there's some applications in quantum computing, and um, I this is like totally speculation, but it's looking hopeful that I may actually take a little bit of a sabbatical at some point.
Oh.
To maybe a little like a part-time sabbatical or something like that.
Yeah. Yeah.
To help with some of these projects, and this is funded on the quantum computing initiatives. Now, but as far as quantum computing goes, I'm still a skeptic.
Okay.
Okay.
Sure.
Because I know what it was like. Oh man, this is like formidable. Like, how are you doing this? Um, but yeah, it's for real. It's
Neat.
for real.
Cool.
That's good. Again, that's a game changer, and it's a whole different world. It's not going to be like conventional computing, and people just
Right.
need to, get that out of their head.
I'm not going to have a quantum desktop.
I don't think so.
Okay.
Now there could very well be some design breakthroughs, some idea breakthroughs that come from the core stuff that researchers are working on now.
Okay.
That could actually translate into some really, really interesting things happening on the desktop.
Neat.
But it will, you obviously can't be cooling something down to fraction of a degree Kelvin with liquid helium on your desktop, right? Yeah, this is one of those things, kind of like. Just as far as that goes, I'm going to characterize it as like the space program.
Okay.
Because back in the 50s and 60s,
Yeah.
we got things like microwave ovens and stuff like that.
Sure.
We got all kinds
Velcro.
of cool stuff. Velcro, yeah, greatest
Memory
thing
foam.
ever, right?
Yeah. That's cool. Okay. So there may be sort of tangential or we might figure out some other cool stuff as we walk this path of quantum computing.
Yeah. Whenever you throw money at brilliant scientists, eventually good things will happen. Okay. And it may not be related to what they were trying to achieve in the first place.
Still, that's cool.
But
creative solutions.
I think the money is well spent. I think the funding for the research and the projects that are going on are well advised. I think it's well guided.
Cool. That's good to hear. It's not just junk science almost, That's good to hear.
Yeah, it's very, very tricky. Insane challenge.
Neat.
But great research. It's
Right on.
Fantastic research.
Cool. Well, okay. So we'll end it here on a science fiction note. I think this will be really cool. But so thank you, Don, for joining us on our Labs Open Office Hour. It was very kind of you to take time out of the day and join us today. And I want to thank the audience as well for joining us. Thank you for your questions. I think we got some really good stuff out of that. We do this every Wednesday and Friday at 1 p.m. Pacific. Wednesdays, we bring on industry experts from outside the company to give us a little insight into their workflow and process. And on Fridays, we have a member of our labs team, like Don here, kind of spread a little bit more of their knowledge and expertise around, and then take questions from you guys as well to get a little more insight into the overall kind of crossover of hardware and software. So mark your calendars, Wednesdays, Fridays, 1 p.m. Pacific time. And we will say goodbye.
Take care, everyone.